Hi, this video I'm hoping to teach you about standard form of a quadratic function. Standard form of a quadratic function looks like this: y equals ax squared plus bx plus c, where a, the coefficient with the x squared, is your stretch or your dilation, and the c is actually going to be your y-intercept. We'll talk a little bit more about that later. This form isn't the best because it doesn't tell you that much when you just look at it. You can see the stretch and the y-intercept, but you don't know the vertex. So it's a little bit tricky to pull a lot of information by just looking at the form itself. You have seen this before back in chapter 3. When you did quadratic regressions on your calculator, the quadratic function was given to you in this form. If you remember, when you plugged in a whole bunch of data points and fit it to a parabola, this was the form it came in. So if we ground ourselves in what's happening in this chapter, you're seeing this slide quite a bit. Now this video, we're in standard form, one of the three forms to represent quadratic functions. We'll talk about it and talk about graphing parabolas from them as well. I have two examples. The first one here, you can see our parabola is y equals x squared minus 6x plus 5. When you are in standard form, a helpful thing is to really ground yourself in what your a, b, and c values are. So on my page, I'm going to remind myself that my a value is 1, my b value is -6, and my c value here is 5. The reason that's important to think about and know is because to find the vertex, we're going to use this nice little formula, opposite of b over 2a. So if I'm solving for x, opposite of -6, opposite of b is 6, and then 2 times a. So I simplify that, and I get an x value of 3. Now it shouldn't be too hard to find our y value. Let's just plug that back into our equation. Every time we see an x, we're going to plug or substitute in a 3 instead. It looks like, no, why did I do that? That's a 5 there. -9 plus 5, I was getting ahead of myself in my head, is -4. So we have a vertex of 3, -4, and I already have that plotted on my graph right there. So that's nice. Now I feel like I have a much better grasp on what's going on in this parabola. My axis of symmetry is that vertical line, x equals 3, because I'll remember that my axis of symmetry and the x value of my vertex will match. You technically don't need to draw in that axis of symmetry. It's not a part of your parabola, but if it helps you draw and stay symmetrical, I'm all for it. This one is going to open up because my a value is positive, a equals 1, and then I remember my pattern of change, 1a, 3a, 5a, so it's going to be 1 times 1, 3 times 1, 5 times 1. So from my vertex, I'll go up 1 to the right 1, up 3 to the right 1, up 5 to the right 1. And then I'm going to want to make this look as curved as possible. It's not a V, it's a U. Connect those points the best you can. All right. And then one more thing to talk about. Remember how I promised the y-intercept is the c value? So in this case, it says the c value is 5. And I look here, and sure enough, I see the y-intercept is at the point 0, 5. Let's take a second to just prove that algebraically. A y-intercept, the x value will be 0. So into my function, every time I see an x, I replace it with a 0. Well, 0 squared is 0. Anything times 0 is 0. So I end up with a y equals 5. So graphically, I can see the y-intercept is the c value of 5. Graphically, I saw it, and now algebraically, I proved it as well. So it's kind of a nice little trick to see when you're given the standard form of your equation, you know right away where your y-intercept will be. So you already have a point on your parabola already made. All right, here is another example. It's already completed. If you want to pause the video for a minute to copy this down, it's a little more complicated because the vertex isn't on integer points, not an integer for the x or the y value, but everything else really is the same. Nothing will change. The process is the same. Let us know if you have any questions. I hope you found this helpful.